Now, you have to differentiate between the solubility or the solving between a polar compound and non-polar compound. We know that the rule of solubility said that light dissolves light. What means light dissolves light? It means that polar dissolve in polar and non-polar dissolve in non-polar compound. But there is an exception because of the characteristic of the water and the capability to form a hydrogen bond, also the intermolecular attractions between the molecules of the water. So let's take an example of a covalent bond of a molecule, a polar one, polar compound, dissolved in polar compound. A polar compound example, we have here HCl. What is the HCl?
Hydrochloric acid.
Hydrochloric acid. The HCl is a polar compound. When it's dissolved in water, it's forming a plutonium ion plus Cl negative. Here is water. But we don't find in the solution, we don't find the hydrogen positive ion alone in the compound. It's attached with a water molecule to form hydronium ion, and the hydronium ion is symbolized by H3O. And we don't find the hydrogen ion, we find hydronium ion. So if we wanted to represent this as in a beaker, here is the water molecules, guys, as always. Okay? So which element I put it here? What is this? This is the hydronium. So it's positive, this is the side of oxygen, and here the chlorine negative. Okay? I want you to remember this pages because we needed when we talk about the last part or objectives in this class about the electrolyte and the molecule. What about the non-polar compound like ethanol? It's have another name, ethanol or ethyl alcohol. Anything that ends with OL is considered as alcohol. Ethanol has the chemical formula of, or molecular formula, C2H5OH or CH3CH2OH, or the structure formula three hydrogen atom in this carbon. This is the structure formula. As you see, this is here ethanol is not a polar compound, it's non-polar compound. How it's dissolved in water? It's dissolved because, or the sucrose, for example. We will give us the two examples. The sucrose. The sucrose, the sugar, is C12H22O11. This is the sucrose, non-polar compound. The sugar actually dissolved in the water and it's a non-polar compound. So how is it dissolved? The only thing that changed, guys, here, when we dissociate this in water, he only converted to an aqueous solution. See, here it was, for example, here was a solid, or converted to an aqueous solution. Here the ethanol was liquid, and he convert, when he dissociated in water, he converted to C2H5OH, but an aqueous solution. If we go back, this is very clear here in the PowerPoint. If we go back here, you will find it's very clear that there is no ions formed. It's the only thing that happened to dissolve this compound is the water or the solvent molecule surrounds the molecule or the non-polar compound. So it's dissolved and form a solution, but because of the unique characteristics of the water. Okay? And you can see that from the molecular structures here. Do you see that? The water molecules surround the ethanol molecule, also in the ethanol. Here, this takes us to a second type of mixtures, or another type of mixture is the suspension. The suspension is a particle in a solvent are so large that they settle out unless the mixture is constantly stirred or agitated. Okay, agitated means shaked or stirred also. Okay, the mixture is called suspension. The mixture is called suspension. Remember, the only huge difference between the solution and suspension, there is a lot of difference. First thing, solution is a homogeneous. Second thing, suspension is a heterogeneous, not homogeneous. Because, for example, a jar of muddy water, I could see the component, I could see the mud and see the water, and I know this is composed of two different components. So definitely it's a heterogeneous. Also, the scale of the diameter of the molecule or the particles imposed of that. The solution is very small particle. We talk about atomic or ion or small molecule scale. Here in the suspensions we talk about larger scale. So, for example, a jar of muddy water, as I said, the particle size is over 1000 nanometer. For the solution, the particle from 0.01 to 1 nanometer. This is the range or the scale of diameter for the solution, because we talk about atomic scale. Okay, the third one is the colloid. Colloid particle that intermediate in size. So we have solution is the smallest, suspension is the largest, colloid is in between them. So what is the colloid? Particles that are intermediate in size between solution and suspension form a mixture known as colloidal dispersions or simply colloid. The particles in a colloid are small enough to be suspended throughout the solvent by a constant move of the surrounding molecules. Colloid particles makes up the dispersed phase, and the water is the dispersing medium, so the medium that the solvent inside that component. Example, mayonnaise is a colloid, and fog in the morning is a colloid, so it's considered as a heterogeneous. There is much similarity between the solutions and the colloid because of the size of the particle of them are much closer to each other. The scale of the solution, as I said, from 0.01 to 1 nanometer. Colloid is intermediate between suspension and solution, so it's from 1 to 1000. So this makes some similarities. So how we could differentiate between solution and colloid? Very simple. This takes us to the property here, Tyndall effect. The Tyndall effect occurs when light is scattered by a colloidal particle dispersed in a transparent medium. For example, headlight beams is visible from the side of the flying eye. The Tyndall effect can be used to distinguish between what and what, between what and what?
Solution.
And colloid. And as you see here, this is here two jars here. You will find this is particles here is scattered and increase the intensity of light. So definitely this is the colloid or a solution. This is a colloid, but this is a solution because the beam of light passes without having any scattering. The light passes through the transparent medium. Here, the differentiations between the three of the mixture that we talk about: solution, colloid, and suspension. The solution is homogeneous, colloid heterogeneous, and suspension is heterogeneous. The particle size from 0.01 to 1 nanometer can be atoms, ions, or molecules. Particle size from 1 to 1000 nanometers is a little bit larger molecules. Particle size here over 1000 nanometers suspended can be large particles or aggregates. Do not separate on standing. What does that mean? For example, the jar of muddy water, if I left it for some time, what happened?
The mud
will settle down to the bottom of the beaker or the jar. This is why this happened for the suspension only. But in the case of the colloid and solution, this will not happen. If I have a salt water and I left it for 2 days, for 5 days, for a long time, I will not find the particle of the salt settle down because it's already dissolved, and the water molecules, it's converted to another scale. It's converted to atoms or ions or small scale. Finally, how we could filtrate. The solution's particle is very small. If I'm using a filtration paper, it will not filtrate, right? The same as the colloid. The particle is much similar or intermediate in size, so it's not filtrate or if we're using a filter paper. And the suspension, it could be filtrate if I'm using by any way of filtration like a filter paper. If I put it and I put the muddy water inside it, it will separate the mud from the water, right? Yeah. So we could separate this. Here in Tyndall effect, the solution does not scatter the light, but the colloid scatter the light and have a Faraday line. The suspension may scatter the light, but are not transparent, it's opaque. The last part in this section is the electrolyte and non-electrolyte. Solutions is classified according to electrolyte or non-electrolyte according to their conductivity to electricity. Some solutions conduct electricity and we name them electrolytes, and some solutions do not conduct electricity and we consider them as non-electrolyte. So the question here, why some solution could conduct electricity and another not? So this takes us how actually the metal, if we ask ourselves, how actually the metal was conducting the electricity and what is the responsible for conducting the electricity. If we have an example of a metal, like copper, a wire of copper, and we draw each ion here, this is the atom or the nucleus of the copper, surrounded by again, what you say? Free electrons. Around this, we will find a sea of delocalized electron. This is free motion of these electrons is responsible for conducting the electricity. So I will get back to the previous pages to see if you could observe which is one will be a conducting electricity and which is one is not. Here, this is free delocalized electron. Make the metal capable to conduct electrical current. So as we go back and we see the dissociation here for a polar compound, for example, what do you observe here? What we name this?
Ions.
Free ions. So the free ions is responsible for conducting the electricity. And here also sodium chloride is a free ion. But in sugar or ethanol, does it form an ion?
No.
So we have here the polar compound is electrolyte or non-electrolyte?
Electrolyte.
But the non-polar compound forms non-electrolyte. Why? Because it does not contain free ions that could conduct electricity. And we can see that from this experiment here, when we try to distinguish between the electrolyte and non-electrolyte, you could see that, for example here, that the cross molecules, it's dispersed, distributed around the water molecules without actually conducting the electricity because there is no existence to the free ion. Here, for the acetic acid, it conducted the electricity but not much as the sodium chloride or as hydrochloric acid. Because electrolyte could be classified in weak and strong electrolyte. It depends on what? Depends on the amount of free ions. As you should see here, the acetic acid not completely ionized. Some molecules convert to ion, and then the ions could be attached. It's a reversible reactions, could attach again and form the molecules. So there is no much ions here to conduct electricity. The sodium chloride ionic compound, when we make a solution to conduct electricity also. Here we have hydrochloric acid, has the hydrogen and chlorine free ions, amount of them. So it's a strong electrolyte. So finally, we talk about the three types of mixtures. Solution is a homogeneous. Colloid is a heterogeneous, suspension is a heterogeneous, and finally we distinguish between electrolyte and non-electrolyte. That's the end of the section. Thank you.